Hello everyone. In today's section, we're going to see about half subtractor. So to design half subtractor, we should be knowing the basics of digital electronics. If you do not know, please go through my previous videos. So first, let's start with the truth table. So in the truth table, we will be having two input variables, that is A and B. For half subtractor and half adder, we will be having two input variables. For full subtractor and full adder, we will be having three input variables. So starting with two input variables A and B. And for any subtractor, the output is going to be borrow and difference. Okay. So going for the all possible combination of the two inputs A and B. So we will have 0, 0, 0, 1, 1, 0, and 1, 1. So to fill up the truth table, we should be knowing the binary subtraction, basics of binary subtraction. So let us start with the 0 and 0. Right. So first we will be calculating both the borrow and difference simultaneously. So first one, when A is 0 and B is 0, 0 minus 0, there is no difference. So it is 0. Since there is no borrow, we will also have a 0 on the borrow. 0 minus 1. Okay, according to the binary subtraction method, 0 minus 1, we will be having a borrow of 1 and a difference of 1. Next step, going to 1 minus 0. 1 minus 0, the difference is 1. There is no borrow, hence we can write a 0 on the borrow side. Again, 1 minus 1, the difference is 0. Again, there is no borrow, so we can write a 0 on the borrow side. So this is how we fill up the truth table. The next step after filling up the truth table is going for the K-map. So again, here we are going to have a two variable K-map because we have only two variables in the input A and B, and number of K-map is going to be also 2 because we have only two outputs, which is borrow and difference. So we will be having a separate K-map for borrow and a separate K-map for difference. Fine. So first going with the difference K-map. So we have A on one side and B on the other side. So the possible combination of A is 0 and 1. For B is also again 0 and 1. So let's see the difference. So we have 1 in two places. So when A is 0 and B is 1, we have differences 1. So when A is 0 and B is 1, we have differences 1. Next one is when A is 1 and B is 0, the difference is 1. So when A is 1 and B is 0, okay, so the difference is 1. For borrow again, we have a two variable came up with four sets, A taken on one side, B taken on the other side. Possible combination of A is 0 and 1. Possible combination of B again is 0 and 1. So for borrow, we have only 1, 1, okay, and it is taking place when A is 0 and B is 1. So when A is 0 and B is 1, we have a 1 here. These ones cannot be grouped together as 4s or 2s, hence they have to be grouped only separately. So grouping this one separately and this one separately, the equation for this one is going to be AB bar, and the equation for this one is going to be A bar B. So difference is equal to AB bar plus A bar B. Okay, but we all know that this is the equation for XOR gate. XOR gate A XOR B is equal to A bar B plus AB bar. So we can take that difference is equal to A XOR B. Similarly, plotting for borrow, we have only 1, 1, hence it has to be grouped separately. So it will be nothing but A bar of B. So borrow is equal to A bar B. So now moving on to the final step, which is nothing but drawing the logic diagram. So we know that the difference is A XOR B and borrow is A bar B. So first we will draw an XOR gate. Fine. So the two inputs are going to be A and B, and the output is going to be the difference, which is nothing but A XOR B. And the next it is going to be borrow. Borrow is nothing but A bar B, right? So A bar B. So it is an AND gate, which is a multiplication of A bar and B. So first draw an OR gate. Since it is A bar, we can take a line from A, okay, and pass it through the NOT gate so that it becomes A bar. Okay, so we know that NOT gate inputs and outputs. So A is converted to A bar here and given as the first input. B we can take directly from the previous input and give it to the second bit. Okay, fine. And so the output taken at the third pin is nothing but borrow, which is nothing but A bar. I hope you found this session useful. So in the next session, I'll meet you with the design of full subtractor. Thank you.